So for part one of today's experiment, what we're going to do, if you notice here, there's two things that we're going to vary. We can vary in this equation. We can vary the hanging mass. Well, let's go back to this picture here. What you're going to do in today's experiment is this. So you're going to have your setup with the forces, F1 and F2, and what you're going to do is you can move the hanging mass to different positions. So then one thing you can vary is the distance, the value x. You can vary that. And something else that you'll be able to vary is how much mass you hang. You can hang more mass or you can hang less mass. So you can also change the mass. So that's what you're going to vary in today's experiment. But it's going to be done in 2 steps. So in part 1 of today's experiment, you're going to keep the mass constant, and you're going to vary the distance x. So if you solve this equation here for x, f1 of x, if you do the algebra, it'll come out to be this. Minus the hanging mass times g over L, and plus the hanging mass plus the mass of the ruler over 2 times g. I'm missing something here. Oh, x. So in this part 1, you're going to vary x, and you're going to remeasure the corresponding force. So let's see what this is going to lead to here. If we write this equation like this, y is equal to slope times x, and I'm just going to ignore the intercept. But here this tells you that if you plot force versus x, the slope is going to be equal to, I'm going to shorten it to variable z, and that variable z is going to equal this thing here, which is going to be the hanging mass times g over L. So for part 1 of today's experiment, what you're going to do is you're going to make a table where you're going to vary the distances x, and you're going to, at each distance where you move this hanging mass here, so at each distance where you move the hanging mass, you're going to measure the corresponding force. And then you'll plot that. So you're going to plot F1 on the vertical axis and the distance of that hanging mass along the horizontal axis. And when you do, the slope that you get is going to correspond to this value here, z or mg over L. And you'll just do a comparison with your calculated value for mg over L, and you'll compare that to the actual slope from the experiment. So you'll do a percent difference between your slope and this value z here. The equation is going to look complicated, so I'll just leave it at that. So you're going to do a percent difference that compares the slope to that value z to see how close this equation matches what you observe. So part 2 is going to be similar. So for part 2, you're going to keep the distance constant, so constant x, and you're going to vary the mass. So what that means is, going back to this setup, so now the distance is going to be fixed. You're going to keep it at one position for the whole experiment. And now what you'll do is you're just going to change the mass. You're going to make the mass bigger, and each time you increase the mass, you're going to record the corresponding force F1 each time you increase the mass. So if you were to solve, again, this equation here, but now solve it for the hanging mass, this is what it's going to come out to be. So F1 versus as a function of the hanging mass is going to be gravity multiplied by this factor, which is 1 minus the distance of the hanging mass over the length of the meter stick, and here that number is constant, and then multiplied by the mass, which is changing. And there's also a y-intercept, which is going to be plus mass of the ruler times g. So again, here if you compare this with just a standard slope equation, this is going to have the form y equals the slope times, here we're varying m, so times m. So here then the slope is going to represent this whole thing. And since this is a lot of equal letters, so we're going to shorten it to a new variable. And so this new variable, we're going to call it w, and that's going to equal g times 1 minus the distance of the hanging mass over the length of the meter stick. And again, what you're going to do is here, you're going to make a table. And now you're going to make a table where you're going to have different masses. And for each mass, you're going to record the corresponding F1. And once you've done that, you're going to plot F1 on the vertical axis and the mass on the horizontal axis. And again, you'll get a straight line. But now, in this case, the slope here for that straight line is going to correspond to that variable w. And you'll complete this experiment by just taking, again, a % difference between your actual calculation for w using this formula. So you'll take a % difference between the variable w and the slope that you get from your graph. All right, so that completes the theory part for the torque lab. So again, you'll be doing, so the setup is going to be a ruler that's going to be hanging, that's suspended by 2 strings, and the strings are connected to 2 force meters, F1 and F2. And along with that, you're going to have a hanging mass. And what you're going to do for the experiment is, for part 1, is you're going to move the hanging mass back and forth. So you'll take the hanging mass and change its position. So you'll change the value for the hanging mass x. And then for each x, you're going to record the corresponding force. That's going to be part 1. And part 2 is you're going to keep the mass, you're going to keep the position constant, and what you'll do is you'll just increase the mass. And for each time you increase the mass, you'll also measure the corresponding force.